Good morning, students. Happy to meet you again. I hope the exercise after the lesson last week helped you in mastering the properties of angles. Today, we continue with angles, and the lesson is properties of angles associated with parallel lines. For the plan, we'll have an introduction, followed by explanation of parallel lines, then supplementary angles, alternate angles, corresponding angles, and vertical. So, as I said last week, we examined some properties of angles, and today we are going to continue with the properties of angles, but this time the ones which are associated with parallel lines. What are parallel lines? Parallel lines are straight lines which are the same distance apart, and if they are the same distance apart, they will never meet. You find that on the diagram below. These two lines here are parallel, so they will never meet. So the distance between these lines at any point is the same. These two lines too are parallel, and they will never meet. When you have a pair of parallel lines, you indicate them with arrows of the same type. Like these two, they have arrows of the same type. These ones, they have arrows of the same type. That's how you indicate parallel lines. And we'll be looking at supplementary angles. When a straight line crosses parallel lines, there is a pair of supplementary angles. In other words, angles whose sum is 180 degrees. So look at the diagram. This line is parallel to this one. So when you have a straight line cutting across two lines that are parallel, then this angle A and B will sum up to 180 degrees. So this is a pair of supplementary angles. And equally, C and D will be another pair of supplementary angles. So immediately you find two parallel lines cut across by a straight line, you should know that this angle plus this will give 180 degrees, and this plus this will also give 180 degrees. So if you have given C, you can find D. If you are given D, you can find C by subtracting the one that is given from 180 degrees. We move to alternate angles. When a straight line crosses parallel lines, there is a pair of angles which are equal to each other, and they are called alternate angles. So again, this line is parallel to this, and this line cutting across. This angle is alternate to this. So these are alternate angles, and alternate angles are the same. So Z equals Y. So we are given parallel lines with a line cutting across, and this angle is known. You have already known this. And following what we said before this, you can find also this. Okay? Corresponding angles. If you have two parallel lines cut across again by a straight line. We call these angles, look at them carefully, they look the same. They are called corresponding angles. The positions look alike. They are called corresponding angles. And corresponding angles are the same. So S is the same as T. Done with that? We go to vertically opposite angles. Again, we have two parallel lines cut across by a straight line. Is it? We want to identify angles which are vertically opposite. And here, A is vertically opposite to B. And then C is vertically opposite to D. And vertically opposite angles are the same. So if A is vertically opposite to B, A must be the same as B. So A equals B. And if C is vertically opposite to D, then C equals D. To master the properties associated with parallel lines, of angles associated with parallel lines that I've just explained, you will get back to your textbook and you will do exercise 7.5 and 7.6. The textbook is Pressbook Mathematics, Secondary Mathematics, page 148 and 149. Where you have a problem, go back to the lesson. You can replay it as many times as possible and make sure that you get the right answers to the exercises. So we have come to the end of the lesson for today. Thank you very much for the patience. Thank you very much for listening. See you next time.